Ja, hallo, Test 1, 2, 3. Test. Test. Test, 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 test.
There will be more breakfast later,
Yeah.
in 1 hour or so, which is today. Yeah, just
Oh,
mentioned.
there's more breakfast coming in, or?
Yeah, we had problems with breakfast, and now we have redundancy,
Alright.
and that might be it.
Alright.
I would say just start.
Yeah. Yeah. Guys, we're starting the talk if you're interested. Alright. There's more breakfast later if you're still hungry, because we ordered twice. So I'm gonna present to you Sebastian Jordan. He contributes to Nix packages occasionally, and he's the maintainer and code developer to PyPy to Nix. And in his day-to-day, he watches way too many cartoons. Give it up to Sebastian Jordan.
Good morning. Yeah, I want to talk about PyPy to Nix and Nix packages Python. And the goal of this talk is basically to give you an overview about what these tools are doing and also ask for help a little bit, but more on that later. Yeah. What is PyPy to begin with? It's the official way to install Python packages, basically. Probably everybody who used Python software at one point said pip install package X, and that's how it was done until now. And we want to basically change that to use Nix instead. There are a lot of packages on PyPy. As of the day before yesterday, 120,000. We probably won't be able to support all of them, but shoot for the stars, right? Python packaging has some issues. I don't know if you've ever written a Python package, you probably know that you have to write the setup.py to make your Python code into a package. And this setup.py is just a Python script. So you can put any code in there, and a lot of people do that. Like if it's Windows, or I don't know, if check for certain C libraries and do something else if they are not there, and stuff like that. So there's actually no way in general to get, for example, dependency information before you run the setup script. But pip gives some meta information about installed dependencies when you installed or when you build a package. There's real metadata. Real, by the way, is a binary format of Python packages. And in there you can find some information about what was done, what was installed. And we will see later that we pass exactly that kind of information. And there's another problem there. Because it's not a compiled language, there's no configure phase or anything. So if we want to build our Python environments, we also have to make sure that when we call our executable or import certain modules, that the linker path is correctly set. And as I've already said, we pass the real metadata, and because it's not such a simple step as, for example, with, I don't know, Cabal to Nix, if anybody knows that probably, or Node to Nix. Yeah, we have to do a lot more, we have to do a lot more stuff to get where we want. We do that in 3 stages. And yeah, the first stage is basically just pip install. We build an environment where pip is available, and also your C dependencies that you need for installing your Python packages. And in this environment, which we create just with Nix shell, yeah, we run pip install. That's it. Stage 2 is there to extract the metadata from the wheel, like license or dependencies, author and that kind of stuff. And in stage 2, we also calculate the checksums that we put in our to be generated Nix expression. Yeah, that's stage 2. And stage 3 is just generated Nix expression from that. Yeah, our Nix expression, or Nix expression that we generate with PyP2Nix have 2 parts, or 3 parts maybe. Of course, we have the machinery in place to build Python packages with the tooling from Nix packages, but mostly it is just the generated expressions for downloading and building Python packages as you would find them in Nix packages, basically, because we use just build Python package from Nix packages. And there's an overrides part, which is similar to an overlay. It uses the overrides. First of all, the overrides are there to give the user the ability to insert like special information that PyP2Nix couldn't find. For example, dependencies that PyP2Nix wasn't able to pick up because they were not declared properly in the Python package, or special flags that, or like not flags, special environment variables that should be set on build time. And we use the fixed point calculation similar to the overlays. And I will later show how this might look. Yeah, this is just to give you, to show you this is nothing special. Like, this is part of the generated package set for CFFI, and it just looks like you would expect it in Nix packages. This is an example for overrides. Fortunately, this is not an overlay, so we can do stuff like packages in Python there in the top, because our self and super attributes in this case are only the Python packages and not Nix packages. Yeah, but here, I mean, it's a little bit cut off, but you get the idea. We just override the derivation to remove some stuff that we don't want to have in our setup.py, for example, version pinnings, because we want to take care of that. Yeah, but nothing special, I guess, if you've ever overridden any derivation. Yeah, now comes the fun part, the live demo. Yeah, I prepared a makefile, and let's first look into that. Is this big enough to read? Most people, or people who work with Python probably know about requirements.txt, but just to summarize, it's basically a format, like the requirements.txt file is usually there to specify what should go into, for example, the development environment as Python dependencies, or even in the production environment. And the format is you just list the packages, new line separated, basically. You can put more than just package names in there, also version pinnings, but we won't do that in this example. Or you could reference Git repositories. And yeah, we also have to install Pipey2Nix. That's this part. And then we generate our Nix expression with Pipey2Nix. And this is basically the example invocation for this case. I will quickly go over the flags. Pipey2Nix supports Python 2 and Python 3. And the first flag, like the -v3, just says, yeah, use Python 3. The -r flag is similar to the pip -r flag. It specifies the requirements txt file that should be used to generate the Nix expression. The -e flag lets the user specify Nix packages that should be available at build time or at pip install time. And minus lowercase v is just, yeah, verbose output. And yeah, let's do that. So yeah, nothing in here. And now we want to make our requirements. .txt file, nothing special, just, yeah, there's everything in there. Now let's generate the requirements .nix file. Yeah, this takes, I don't know, 30 seconds or a minute because it has to compile some stuff. In this case, we built LXML, which is just like one of the more famous XML parsing libraries for Python. And I chose this example to demonstrate that we can handle, yeah, C dependencies. Yeah, and here you can see, yeah, we just run pip. Yeah. I don't know, maybe we have to wait a little bit. Maybe, I don't know, has somebody questions so far? Maybe we can do that in the meantime.
Can you reuse the override?
Sorry?
Can you reuse overrides that are previously created in Nix packages?
I'm really sorry, I didn't get the first part.
The question was, can you reuse overrides?
If we can reuse overrides. Like that you created for a specific environment. Yeah. Yes, there is a way to. Let's just show this. No. Result Pipey2Nix. There is a flag that lets you specify additional overrides. I don't know. On the screen, it's still there. So anyway, there is this -- overrides flag that lets you specify any override file that you previously created. You can even get your overrides file from URLs or Git repositories with the exact revision that is currently at master, or you can even specify another revision. So there is a way to reuse overrides, and I will talk about that later a little bit.
One small question. So this LXML library also depends on libxml2, right?
Yeah.
How can the generator find that dependency? Do you have to specify it manually, or?
Yeah, that's a little bit dirty secret of pip2nix. When you specify, you need LXML, libxml2 and XSAT, it will just be there for every Python package, because we cannot, in general, get information about which package exactly uses the C dependency. So we just give it as a build input to all the Python packages in the whole set that we just generated.
The Python packages can be derived from.
Yeah, the Python dependencies are derived from the pip build output. Okay, I will continue now with the demo. We just generated the requirements.nix file. And like this screen, which is also connected to the computer, shows everything constantly. So I don't know. Yeah, here's the generated expression for LXML, and in the okay. I mean, in this case, LXML has no Python dependencies, so in the propagated build inputs, it's empty, it's an empty list. And here is the dirty hack I mentioned earlier. The common build inputs are now libxml2 and XSAT, and this would be true for all the Python packages that we would have put in there. And just to show that it works, let's make the interpreter huh? Ah. No. Ah, yeah. This builds instantly because I previously tested it on this computer, so you have to believe me that Nix ran. But yeah, let's quickly start up the Python interpreter and import LXML. Yeah, works. Okay, let's go on with the presentation. Okay, so now you've seen what works. You've seen that we can generate Python environments and that we can use them, but there's a lot of stuff that doesn't work for now. And this is especially tests. And this is a big issue because we really have to support tests to make this a viable option, maybe to use the Nix packages. And even not, like, this is just necessary to, if you want to use this in production. We don't support multiple PyPy instances, so if you have a private PyPy server, you cannot use pip2nix to like selectively pull from official PyPy and your custom PyPy server. This is due to, at least to my knowledge, pip has no way of telling the user from where it got the packages. Like, of course, we could parse it from standard out, but yeah, we don't want to do that because it would break every time pip updates. We don't want to rely on the front end of pip to generate our Nix expressions. Yeah. And if anybody wants to do that, feel free to contact Rock or me. Yeah. How much time do I have? 10 minutes. Okay. Now I want to quickly talk about Nix packages Python. Nix packages Python is a collection of Python packages that are generated with PyPy2Nix. And there is a GitHub repository called Nix packages Python, which Rock owns. And yeah, it's semi-automated self-updating. What that means, I will explain that later. It offers binary substitutions because we push build artifacts to the binary cache via SSH. And it also serves as a library for common overrides. Semi-automated self-updating sets of Python packages. Yeah, we automated this with Travis CI. And there's basically a cron job running every night which executes PyPy2Nix and generates expressions which can be used by the user. And it commits its changes that it made maybe because of a Python package update upstream or whatever to this repository back. There are multiple Python sets. Yeah, like all the great stuff you know or use, but yeah, by far not everything. Like for example, Django. I think it's only Django. It's no plugins, no extensions by now, but we plan on expanding that. And they are organized in groups that make sense. Like yeah, you would put, for example, PyTest with its extensions in one package set because you have to make sure that these work together, and this is how we organize it for now, especially to mitigate like really long build times. Yeah. And yeah, different versions for Python 2 and 3. I mean, this won't be an issue for too long, but for now it is. Yeah, it's a library of common overrides. That means like there are already predefined overrides that you can use, and PyP offers a --default overrides flag that pulls automatically the overrides from Nix packages Python in your Nix expression. This is also like it depends on the revision of that was current when you executed this command. So if you generate the Nix expression, it won't break in the future, even if we update something that might break your old expressions would still work. This is not the default behavior, but it is planned to be the default behavior soon. What we want to do is, with Nix packages Python, we want to provide an easy way to install your Python packages. And for that, we would like to use overlays, maybe like as intended. And there is already an overlay definition in the repo, but that you could use. But yeah, as we saw yesterday, it still needs some overhauling. And we could generate a static PyPy from our expression. That would be also really nice to help with, I don't know, generation of Docker images or whatever, because if you have a PyPy repository with only the versions you really need for the job, you don't run into trouble with like version fuck-ups or whatever. To enable tests, we need to rework the Python infrastructure a little bit. If that's possible at least. And there's currently no way to differentiate between build inputs for a package, like test inputs, especially like PyTest, and runtime inputs. from the way we generate our expressions, so we have to figure out something there. Yeah. So now, I don't know, the future. We would very much like to use an automated tool in Nix packages to generate Python packages for basically end-user consumption, or I don't know, for packages that need these as dependencies. I don't know. But we definitely don't support this now. Like, yeah, don't expect us to integrate well with your Nix packages needs for now, because we are just not there yet. We would like to support that, but yeah, for the reasons I already explained, it's a little bit difficult. So what we could do instead is generate a set of overlays and offer that to Nix users. This would probably be like the least intrusive way to get people to know the tool and how it works. Yeah. Building pull requests on Hydra would be nice, but that's probably what a lot of people think. Okay. Yeah, that was my talk. Any questions?
We don't have much time.
Any question?
So there is a new tool called the pipenv by Kenneth Reeds, I think. So it's it's using pip file instead of requirement.nix, requirement.txt, and it generates pip file.log, which have like like the dependency, the version, and the hash of the package. So does that make sense to be used in Python X? It's officially recommended to be used by Python organization.
Okay, yeah, thanks for the hint. We'll look into that. Actually, I didn't know about this pipenv command until now.
pipenv, yeah.
Last question?
So I was just wondering, how do you select which packages to put into an expected Python? Or do you only build dependencies of these three packages?
The workflow until now was, okay, I need some Python packages for my work, so I put it in X-packages Python. So it was basically derived from what I and Rock needed for our purposes until now. Like, so there is no formal specification on what goes into what kind of package set in X-packages Python until now. But we are open for proposals, of course.
Okay.
Thank you.
Just read this, I think.
All right. Next talk is by Dan Peebles. He's been addicted to Nix for the past couple of years, and is now the maintainer of Nix on Darwin. And when he's not trying to wrangle the macOS into behaving properly, he works as a programmer and an official internal Nix evangelist at Bridgewater Associates. Also a Haskell and Agda recovering notes. Give it up.
Thank you. Hello. Okay, it works. Okay, so does this actually make noise? Yes. Okay. Yeah. So I am Dan, also known as CoPumpkin online. It sounds weird to pronounce that, so I try to avoid it. And yeah, so I'm going to talk a bit about Nix and Darwin. That's the Darwin mascot, if you don't recognize it, also known as Hexley. Hexley is a corruption of Huxley, who was actually one of Darwin, as in the person Darwin's strong advocates. But then people misremembered his name and called him Hexley and made him into a platypus demon. The demon stuff is from BSD. The platypus is from who knows. Anyway, that's where that comes from. The other logo you should recognize. So yes, as Jonas said, I am a developer at Bridgewater. I do a lot of Nix at work. I do a lot of Nix at home. It kind of ate up all my Haskell free time that I used to use it for. So if you know me from the Haskell community, that's Nix's fault that I don't participate anymore. But anyway, I think it's working out okay. I also open a lot of issues. That's my greatest pride from yesterday's stats. That's my main job. Okay, so anyway, Nix and Darwin is love, or maybe not, but usually, possibly, it's sort of up in the air. But I'm going to go over a bit of what I'm going to talk about, and then I'm going to talk about it, and maybe I'll talk about what I talked about. So, motivation, why I actually want to do this, why I care, why maybe you should care. Many of you probably don't, but because you're Linux heads. I also use Linux, but I also like macOS. Some history, purity, sandbox, not in any particular order. Those are going to get kind of mixed up. And then a section at the end about where I think we should go and what the current issues are. Notably not talking about Nix Darwin. You should talk to Didard if you want to talk about that. It's awesome. It gives you NixOS-like module support and configuration, declarative configuration on macOS. But I will not be talking about that because I know very little about it. Okay, so the motivation. Packaging purity is not Linux specific, or it shouldn't be. It is, or was until we did this work. Purity is great. We love purely functional designs, and it should be available to more platforms than it used to be. I obviously enjoy using macOS. You can see I've got a Mac here. And a lot of other developers do too. You can see this is a fairly common site, at least on college campuses, but also hackathons, conferences. You will see a ton of glowing apples. They've stopped glowing as much nowadays, but they still are present. But yes, a lot of developers like using Macs, and I would like us to get taken more seriously in the developer community, so I want the Mac experience to be good. And a lot of them are fairly passionate about it too. Like they will go so far as to insult Linux and various things. That's not what I do, but don't do it back. There's also another motivation, which is there is a package manager, or there's a couple of package managers on macOS. One of the main ones is called Homebrew, and it's a huge community. It's very popular, but it suffers from not being Nix. And what I mean by that is, you'll see that the ticket, it's macOS 10.13 is the latest release of macOS. And this was a ticket of like trying to collect issues that came from the latest release. And these are some snapshots, but like this is the actual full ticket as of the time I collected this snapshot, which was this morning. With 122 comments, and there's just tons and tons of build errors because Apple shuffled a few things around and decided to break everyone. And because Homebrew is impure, effectively, and sort of depends on random stuff from Apple all the time, and it's like not deterministic in that sense, they need to deal with it, and they need to scramble to deal with it. They can't sort of upgrade on their own time. It's like, oh, well, Apple switched out everything from underneath us, now we need to deal with it. And so luckily they have a huge community, so that's great. Like they have, I don't know, 50 contributors like just posting on this thread alone, and there are other threads about this upgrade as well. This is just the first one. But it is, it's not really a very sustainable workflow, and definitely not something that would work for us because we have a much smaller number of people working on it. So purity helps us there, and I'll talk more about that later. But anyway, this is one of my motivations because like this purity, the lack of purity makes this kind of stuff much more common and harder to deal with. Another motivation is I use it at work. A lot of my colleagues use Macs at work, and I want them to use Nix. As we said earlier, I am trying to evangelize this at work. It's mostly kind of working, which is another story. But part of that is they're able to use Nix on their Macs and transport their packages to Linux and have it work in exactly the same way. And probably one of the final motivations before I go there is this just offends me, which is the way you get developer tools on macOS the endorsed way, and you need this for Homebrew, you need this for pretty much anything out there, is you install a package, an official Mac package called the command line SDK. And the command line SDK, basically, if you type git on the command line on a brand new Mac, it will pop up a GUI panel saying, would you like to install the command line SDK? And you press yes, and it downloads 150 megabytes of stuff, and then installs for a while, and then you type git again on the command line. And what it prompts you is a message much like that, saying, before you can use it, you must agree to the license of the Apple SDK. And this is for open source software, so their example there is GCC, and before you can ever use it, you actually need to agree to this license, which means rerunning the exact same command as sudo, and it will prompt you with a page of text, or like a pager of text, many pages inside a pager of text. At the bottom, it will say yes or no, and you accept it, and then it remembers that under super user and will never prompt you again. But anyway, that has always been a huge annoyance, and that is just basically my reaction to that, is a rather famous Italian politician there. But anyway, so that's why I care. Many of you will probably say, well, screw that, I'm just going to use Linux or NixOS. I fully understand that. I've been tempted to many times myself, but I keep coming back to this. So, moving on to a few credits before the core content. There are tons of people involved in this. These are some of the names that really popped out off the top there. Jude Taylor on GitHub was instrumental to much of the early work. I will be referencing him a lot throughout the rest of the history of this. Gritophobe John Weagley, who's also guilty of getting me into Nix in the first place. And you'll see down there at the bottom is LNL7, who's in the back of the room, and who has more recently sort of become a major maintainer of the thing and has been doing a ton of really good work here. So one more little piece of background is, before I actually launch into this, I'm just going to explain how Linux works and how a lot of the bootstrapping works, because with any luck, most of you haven't had to deal with it. So standard env, most of us have seen that. Most of us, I hope, haven't actually had to deal with how it is constructed. But it is a bootstrap process starting from a very small tarball of the minimal amount of stuff that we could think of to put in there that would actually construct a viable system on top of it. And so in the bootstrap, you'll find a compiler, a linker, a few core utils and stuff like that. And then everything else is built on top of it, and a bunch of headers, but everything else is built on top of it. That is true on Linux, and it is also true on macOS now, but wasn't true before we started this project. And so the bootstrap process is like a very carefully groomed process of having, in multiple stages, you build one thing or build a handful of things, and then in that those become the standard env of the next stage. And then you're trying carefully to maneuver to avoid depending on things that you don't want to depend on, and it's difficult and painful, and but is something that's sort of once you get it working, generally kind of stays working unless people majorly change dependencies of core utils or things like that. Another sort of key little piece of background information is, you may not know this, maybe you do, Apple publishes a lot of the source to core components of macOS on opensource.apple.com. Calling it actually open source is a bit of a optimistic. Apple was very into open source when they first released macOS in the early 2000s, and actually had an open source distribution called Open Darwin that could run X and was running on the Mac kernel and all that stuff. They lost interest a few years later, and that died. They regained interest, and then it died again. And anyway, they publish source right now. They will not accept patches. So you're not going to be able to do any sort of typical open sourcey things, except for a handful of projects like Swift or whatever on GitHub. But generally, their stance on open source is very variable. So that actually lets me start on the main topic of sort of like how this came to be. The standard env that I'm describing is actually in Nix packages today. Everyone on a Mac uses it, and this is sort of how it came to be. So in the third quarter of 2014 was when I started Nix, thanks to John Weagley, who was walking around a Haskell conference that I happened to be at, offering to install Nix on people's computers. And I said, okay, sure, yeah, you can install Nix on my computer. And I looked into it and got addicted and stopped using Haskell and all that stuff. Yes, so you can blame him for all those tickets that I put in. So Nix packages on Darwin was very impure. And what I mean by that is that bootstrap process I just described wasn't there at all. There was a standard env, and the standard env basically said, my compiler is user bin cc. It's a simplification, but effectively that. And if user bin cc doesn't work, then Nix doesn't work. If you haven't installed that SDK thing that I was talking about earlier, then Nix doesn't work. All that stuff, like you needed to go and do it yourself beforehand. And if someone installed an update to that SDK and it changed the way the compiler worked and Nix wasn't aware of it, then Nix would break, and Nix would break a lot, basically. And so it wasn't very fun. And when I first started using Nix, I made a few little pull requests here and there. But like what became very obvious to me very early was purity envy. I saw the Linux people. It was very pure. It was very nice. It was very deterministic. And then everything was always breaking on macOS. And so I was getting more and more envious of how it worked. And so started doing a few little pull requests here and there. Security tool is a random tool that Apple provides the source to. We used to have a Haskell package, I think an X509 certificate package, depend on security tool, but it was depending on it implicitly and just using user bin security. This was my first ever sort of step in this direction, and compile it from source, still compiled in purely from source, but compile it from source. Because Apple releases the source of that particular tool. And you can see that I was starting to move in that general direction. There's a branch called Mac Purity up there. But this was in sort of 3 quarters through 2014. I shortly after added the command line tools, which is basically that SDK I was talking about before. It's still this big bundle of stuff. There's like a compiler and headers and all sorts of stuff like that in there. And I made a pull request basically adding that SDK. So instead of just depending on it in user bin, we might eventually be able to depend on it, like just use a derivation reference and have it appear in our things automatically and have Nix download it for us. And when I say Nix download it for us, there's a very ugly thing that some of you may have seen there. But there's a password because Apple distributes this thing, or at the time distributed it behind an authenticated web endpoint, and the actual authentication mechanism was ugly too. We had a special downloader for it called fetch-adc. It was horrible. But basically, you needed to put in your config.nix to use this stuff at all. You needed to put a username and password from an Apple account. So that wasn't great. And at the same time, Jude Taylor, who I mentioned earlier, was working on getting Clang to work as a proper standard env in Darwin, because one other thing that I didn't mention earlier is Apple's a big fan of LLVM. A lot of the public LLVM development actually comes from them, and they used to employ the creator of LLVM, who then left, I think, for Tesla or something like that. But they are fans of LLVM in part because it's not GPL'd, and Apple's not a fan of the GPL, and so they used GCC up until like I don't know, 10 years ago. But as soon as the LLVM became remotely viable, they started throwing a ton of money behind it, and so what happened in this 10.10 that he's referring to there is they used to provide a shim, a compatibility shim that allowed LLVM to pretend to be GCC, but they stopped shipping that in 10.10, and so our impure references to GCC would have all broken when 10.10 was released. And so his goal in doing this was not only to get Clang-based standard M working, but also to have not all of Nix break when 10.10 was released. Now, things to note here are you can see just even in the diff excerpt right there, Nix enforced purity is set to nothing. That is a magic environment variable that gets set all over the super low level inside the standard env, and tells the wrappers around the linker and the compiler to not complain if you see a path outside of the Nix store, because that was necessity in the impure days. And the other big thing is there's a very sad user bin right low down there. Kind of everything comes out of there. It's still super impure, but this was a step in the right direction. It allowed us to start moving in the direction of Apple's own tools. But the next big step here was effectively adding a fake bootstrap. And what I mean by that is you'll see there's a trivial bootstrap .sh right there. That trivial bootstrap, and I'm just going to show a little clip of that trivial bootstrap.sh. It's instead of just making references directly to the paths on the file system, which was particularly impure. Instead, I add one level in direction, because that's always the right answer, and stick it inside a derivation. And so the builder of this derivation was just calling ln against the impure paths. And what that allowed me to do was plummet through a little better. And so instead of depending directly on bin.sh, or I guess everything else still depends on bin.sh, but bin.cp, you can now depend on the actual derivation path, which happened to then point to bin.cp, but then someday maybe I would be able to change that. So this was the very beginning of the whole effort, was this file basically. And then that allowed us to start plugging around a few things like this. So this is possibly not the best example, but you can see, actually, there's build tools, instead of actually making a reference to the root file system, now I'm actually making references to derivation outputs. This one happens to be commented out. I missed it, but anyway, it wasn't always commented out. And so what happened next was this make bootstrap tools, because so now we got a fake bootstrap. Now I want a real bootstrap, and so I want to start getting towards what Linux has. Linux has a makes bootstrap tools.nix under their Linux standard env, but obviously doesn't work on us on Darwin, so we needed one of our own. And so I basically, I was still pretty clueless about Nix. I didn't really know a lot at the time, and so I basically just copied the Linux one and made a few changes. What happened to my? Okay, my computer's still on. Yeah, sure. Yeah, I think it's getting there. I think that thing just takes a little while too, or is it?
No. All that thing should be fast. Maybe plug it in on here.
Okay. I can try a different USB-C port. My thing just react. Oh, there it is. Okay. Okay. So yeah. So make bootstrap tools. I was clueless. I copied effectively the Linux makes bootstrap tools, which sort of indicates that this basically didn't work when I first committed it. You can see there's Darwin up there, but I actually refer to BusyBox down at the bottom there, which doesn't work at all in Darwin. So this just would have failed. But it was a start, and we this was basically the beginning of a collaboration between me and Jude on IRC to really like work together on hacking together the very basic bootstrap tools that would allow us to sort of become pure. And so those bootstrap tools, there's a few different components, as I mentioned, like the compiler itself, and then there's the headers. And the headers is actually where the meat of the work went. So I'm just gonna, here's, I guess, evidence of the collaboration. There's Jude, you see up the top there, and me down at the bottom there. There's a lot of commits. Most of them throw away, and most of them have really shitty commit messages. But this can all be found on an ancient branch on my GitHub fork. The headers, there were tons of commits like this. This was basically started in early October and went for basically a month of basically harvesting random packages from opensource.apple.com and effectively looking through the Apple SDK that they published and trying to figure out where the headers came from. Because they usually came from a package that Apple released, but it wasn't always obvious where it came from. And so I needed to go, I effectively had like a script where I listed all the files in their header folder and tried to map it to a package from Apple. And then tried to figure out how to package that in Nix, and then harvested the headers from there and like reconstituted them into something that looks vaguely like Apple's official one. This is all to avoid licensing restrictions because Apple releases their SDK with a different license from the constituent parts of it, and so that's how you end up with that weird licensing agreement there. Even though all the headers and stuff are released under the APSL, which is Apple Public Source License, which is pretty permissive. The SDK itself is rather unpleasant and is much more nebulous about actual packaging there. So effectively, it's figuring out how Apple builds that SDK from all the packages which they release anyway. And so there's a lot of annoyance there around things like if you're just going by header name, it's a lot of the headers there's multiple headers with the same name, which means that if you have the kernel, they release the source code to the kernel. The kernel has, because it has no dependencies, has a bunch of headers of its own and has like a pseudo standard library and various things like that. Those headers are not ones you want to use outside of the kernel, but if you're not careful, you accidentally pull them in from the wrong place and it gets very messy. So that was a pretty painful point, and a lot of experimentation around how to constitute the bootstrap tools. And as far as how I was actually testing this when I was going around, it was pretty hacky. You can see here I have the standard env again with enforced purity equals 1, unlike before. And this was my basically the bootstrap tarball. So we have the cpio.pz2. CPIO is an obscure archive format that's easier to unpack, I guess, than tar. I was just copying what Linux was doing at the time. You'll see that I was actually pretty clueless about Nix because I actually had this path in quotes, and that was just basically relying on impurity to work at all. But it worked, and it was because we didn't have a sandbox or anything at the time. So anyway, I was able to copy and extract the bootstrap tools properly and all that kind of stuff. And so this was effectively how I was testing it. I would run Nix build on make bootstrap tools, see if it worked. If it did work, I'd leave it in that path and then have this other thing consume it and try to actually build stuff from scratch. And it would not work, and then I'd have to amend the bootstrap tools and rerun it and all that kind of stuff. It wasn't very fun, especially since even the way I had the standard env working at the time required 3 different LLVM builds and Clang builds, which are, if anyone's tried them, are very slow. It takes at least an hour probably each for an LLVM Clang build. Depending on how powerful your machine is. And so the iteration time on this was extremely slow and painful, but I since figured out how to make it work with just one, which is much nicer, still pretty slow. And so what this led to was effectively a bunch more badly named commits, and then we actually, you'll see there's Darwin bootstrap tools. This looks much darker here than it did on my original screen, but this was creating the original bootstrap tools. That actually were somewhat viable, and this was kind of the end of one branch. And then I actually fed those into a different branch, and you can see this is the very first time in November, about a month after I started this whole thing, actually using the new Bootstrap tools in another random branch that is now lost, or is not referred to anywhere. And so that was effectively the beginning of like a real, actual pure environment in Darwin. It was miserable getting there. It was pretty nice after that. Although there were still a lot of very slow iterations because it took me a long time to figure out that the 3 clangs were unnecessary. This is where I'm going to start sort of breaking up the sort of the path of history, because a few different things started happening at this point. Like a lot of these, the header wrangling was basically just me working alone on that, and sort of obsessively. And then we had a few different parallel threads happening after this. Effectively, there was on one level there's the we want to refine the standard env. So one other thing I mentioned earlier about Linux was it's very careful about the dependencies it has, because one of the objectives is to not depend on the Bootstrap tools. Like you want no runtime dependencies on them, because I guess it's like a cleanliness thing almost. You don't want to feel like you want to be able to garbage collect it. It's not as if they're actually very large, but it feels wrong to sort of retain a runtime dependency on them, and you want to sort of be completely independent and be able to ship around the standard env closure without them. Unfortunately, my standard env at the time had thousands, or not thousands, but a ton of references to the Bootstrap tools all throughout it. And today it does not, and so this is effectively what it looks like. It's a little snapshot of the dot file that NixStore spits out for runtime dependencies. So you'll see there's no Bootstrap tools in there. And that was an extremely painful process, again, because of the 3 LLVMs. The sort of the key thing you end up doing here is something like that. You put in allowed requisites. Has anyone actually seen that, or very few? I mean, I know a few of you have. That attribute before is its derivation attribute is kind of special. Nix will consume it and treat it as effectively, if you have a transitive dependency on anything outside of that list, it will barf and reject your derivation. There's a few variants on it. You can have just there's the non-transitive version for allowed references. There's you can have a blacklist instead of whitelist, I think. Anyway, this is our final standard env. This was about a month later, I think. We were sort of able to reduce this down to only having a few dependencies, and none of them are the Bootstrap tools. But that was another extremely sort of painful process that I think if anyone wanted to start another standard env on like FreeBSD or some BSD or Windows, they would also have to figure out this kind of stuff. And it's Nix ydepends would have been extremely nice in this whole process. But at the time, it was pretty much get NixStore graph out and then run grep looking for which files in there depend on the undesired package, and then figure out how to get rid of it. But it's anyway, we got there, and the standard env still includes these. In fact, I probably went overboard. Every stage of the standard env includes these, because it makes it much easier at every stage to be able to figure out where the dependencies are. I mentioned the sandbox earlier. We started fairly early on, before having an official Nix sandbox, using some sandboxing tooling inside macOS to do all this same stuff. This was the very first commit that I was able to find using it. You see there's a sort of purification from running in a sandbox. This was very early, and what I mean by that is basically what Nix used to call the truth builds, effectively. And you want to stop your package build from seeing random stuff around the file system, because your build tools, autoconf, loves to look all over the file system, or in many cases does. CMake is even worse at it. We'll go find things that you never even knew you had and use them. And so, at least for purity and possibly security, if you care about that, you want these things to be pure or to be isolated. And so Apple has this sandboxing machinery called Sandbox, also known as Seatbelt. And it's almost completely undocumented, except for like a front end that we can't really use, that they ship with the App Store. And so there's this tool called Sandbox Exec, which will take a scheme program. And yeah, so Apple actually built in a scheme interpreter into their OS. It's not in the kernel. There's a userland library, and then they ship bytecode to the kernel, and the kernel runs bytecode. But it's tiny scheme, and if you actually look around one of the libraries on your file system on a Mac, you'll find the tiny scheme, Prelude, and standard library, and all that kind of stuff. But it's if you come across seccomp on Linux, it's a very similar idea, except it actually has a decent front end. So and the front end looks something like this. So this is the NTP daemon on Mac OS. I just grabbed it off my computer before this talk, and it pretty much every daemon running on Mac OS runs in some minimal permission sandbox like this. So if someone were to find some sort of remote code execution in my NTP daemon, they would not be able to do very much, other than maybe change my time, at least without coupling it with some sort of sandbox escape thing. And so these are files that you can find on your Mac, but are basically completely undocumented. And so like the various capabilities you can grant, process forks, signal, same sandbox, all that kind of stuff. It's quite readable, so you can sort of figure out what they mean by that, but it is not documented at all, other than people reverse engineering it. So we decided to standardize on doing this. We were using a sort of ad hoc sandbox profiles for our Nix builds, and so submitted a PR against Nix. This again is much darker than I hoped, but you can see that very vaguely. You can see me submitting a PR against Nix in the very beginning of 2015 that actually added support for using this automatically to Nix under build use Shroot, which we then renamed to build use sandbox because it wasn't very accurate anymore. And it works in exactly the same way, or almost exactly the same way as the Nix one. Or the mechanism is completely different, but it basically asks, and Nix figures out the complete transitive dependencies of a build from the derivation, and then it makes those all available as read-only inputs to the builder, and then the only writable thing is the output, and it turns off network access, it turns off viewing of PIDs of other processes, all the nice stuff that we're sort of getting in Linux from namespaces, we get from, or not all of it, but most of it, we get from the sandbox machinery in Mac OS. So that was a pull request. It went into Nix. It was very nice, and then it kind of died. So we're going to revive that in Hackathon this year, or tomorrow. There's also just sort of general cleanup. This was another sort of parallel effort happening after we got the initial standard env. A ton of packages were sort of broken in many ways. So what we ended up doing was we were afraid of breaking the 5 Nix Darwin users that existed on main Nix packages. I'm being a little facetious there, but there weren't very many Nix Darwin users at the time, and we were afraid of breaking it. So we didn't just want to merge the new standard env because it was at that point probably worse than the impure standard env. A lot of stuff was broken. So what we did was basically just made my fork into a long-lived fork, and we had a branch on there called Pure Darwin. And I actually opened up the issue tracker on the fork, which isn't usually available by default in GitHub. So this is from my fork's issue tracker of all sorts of things that did not work with the new standard env. And so it's like Python 3 didn't work, Ruby, all sorts of stuff, and we had to go through. And this was a massive effort from a bunch of different people in the Darwin Nix group, basically just fixing everything that we could find and just trying to build random packages, see what broke, fixing them, and going on like that. And so that was quite an effort over the next few months, and the reason, as I said, we were wary of merging. Yeah, it was, that was basically what I was just saying. The fork started to languish, and I was losing my motivation. It was a pain in the ass to maintain the long-lived fork, as is generally true. The merges were painful. Linux was always breaking our stuff because nobody knew about it, and I was sort of the bus factor one for a lot of the standard M stuff. So anytime anything was broken there, I needed to go fix it myself, and I had other things going on. So it sort of looked like it was going to die, or at least seemed to me like it was going to die. But Jude saves the day, and actually went and put in all the effort to actually upstream it, which was great. So that is his pull request in mid-2015, a few months later, basically merging the standard env and hundreds of package fixes and stuff like that. Well, this is those 871 lines are just the ones, the dependencies from the standard env. But then there were many more subsequent changes. Back to master, you can see me being enthusiastic about it because I was like, oh, it's not going to die after all. And it wasn't the default standard env, so it was still just an option. You could flip in config.nix, you could say which standard env you wanted, and we still defaulted to the other one. And then a few months later, he made a pull request switching over the default to the pure Darwin one after we ironed out the kinks. And that's effectively, I mean, there have been changes, but that's effectively the core part that's still alive today. So that's been going for about 2 years now. The more recent developments, I'm going to go into a little bit of stuff that's happened since then in much less detail, also because I'm, I guess, short on time. LNL 7 stepped up, became effectively a maintainer of this stuff, and has done a ton of really cool things. We had a long-standing bug for basically the 2 years up until about a month, maybe two months ago, where random stuff would crash because of weird pure, impure inconsistencies. Because one thing that I didn't mention earlier is the standard env, I call it pure. It's slightly less pure than the Linux standard env, fundamentally, because Apple doesn't want to commit to a syscall ABI for making syscalls to the kernel. And so they actually changed the mechanism occasionally of how that works. And so unlike on Linux, which is pretty stable about that, Apple says, do not write static executables, and Go suffers from this because they do anyway. And instead make all your syscalls through what's called libsystem, which is effectively part of the kernel in many ways on macOS. And so they actually have a tech note on their developer website saying, please do not write your own syscall wrappers because we will break them. And so what that effectively means is either we need to be very flexible in how we make syscalls and like have sort of a bunch of switches inside our pure interface to the kernel, or we need to just be impure and use the libsystem like they tell us to. And so what we're doing is the latter. So effectively everything depends on user libsystem to make syscalls, and that's the libc of macOS. And so what that means is that's an example of the things. So there's a couple of other impurities, and then there's this whole sort of set of other kinds of libraries that are proprietary libraries that come with macOS that are called frameworks, and they're used for a whole bunch of GUI stuff, a whole bunch of like macOS specific things that are all closed source. None of the headers are publicly available, all that kind of stuff. And we had an incompatibility between one which is, it's sort of hard to go into, but effectively we had a pure version of one of those libraries, an impure version of one of those libraries, and they both maintained global state, and they would clobber each other. And so this bug basically plagued a bunch of random programs in macOS Nix packages for the past year and a half, or ever since this pure Darwin thing went in. And LNL just fixed it a couple months ago. So that was a great change because that means the random Go packages no longer crash, and a whole bunch of other things no longer crash, which is nice. We've had countless improvements to the actual set of packages. A lot more things compile. It's very nice seeing random pull requests saying make X something work on macOS. This is another very cool development recently is Matthew Bauer packaged a program called XCBuild. That is, I'll go into that in another slide, but it's actually a big deal. One of the things that I mentioned the homebrew changes for the macOS releases. I won't lie, we actually have had to make some changes for every major macOS release, but they tend to be very restricted. Like we make a small change to the standard app and then everything works again, as opposed to like having to whack-a-mole and fix a whole bunch of packages all over the place. As I mentioned earlier, the macOS sandbox did actually fall into disrepair. We're going to fix it, but it is currently not on by default, and if you turn it on, it breaks everything. Ongoing challenges, I guess Linux users still break all our stuff. It's not their fault because we really have no way for them to test it. I mean, they can submit something to Hydra. They have their own jobs, but nobody ever does that. I'll talk possibly about ways to improve that. Apple is very unpredictable about how they release their source, and Apple users seem less willing to go tinker with this kind of stuff on average. Or at least that's my experience. So what might be coming next? I think we actually have a credible story now for avoiding homebrew, which has sort of been a staple of the Mac developer for years now. I think NixOS on Darwin, Nix packages on Darwin is actually pretty good now, and I basically never use homebrew anymore. I think most people will find that their stuff will just work without homebrew. Puff and Fresh. Brian McKenna has done some awesome stuff on a background Linux VM that sort of just works transparently as a remote builder for macOS, for a remote Linux builder on macOS. So it allows us to build containers and things like that. One other thing we've been looking at is going the other way and creating effectively a tiny Darwin, bootable Darwin kernel for Linux users in a VM. That's also been great. We haven't gotten there yet, but the goal is possibly cheaper Hydra workers or Linux VM for people to actually test stuff on Linux without having to buy their own Mac. Obviously, Borg is a reference to Graham's bot, which will also improve the story there. Nix Darwin, as I mentioned, is great. There's a few other things. I'm very short on time, so just real quick on why XC build is a big deal. The standard M is a pain in the ass to maintain. Like some of the derivations or the builds look like that, and that's because Apple has this proprietary build tool called Xcode Build that it ships with Xcode, which is very proprietary, and a lot of their open source releases use it to build their stuff. And so what we had to do is sort of expand the build ourselves and translate it into something like this, which is horrible, and this could just be translated now to a call to XC build, which is great. And so we're going to look to integrate that into our standard env and kill a lot of this kind of junk. Maintainability, that's just like general standard env annoyances, and that's all I got. So thank you. I don't think I have time for questions, but you can try. Any questions? There are probably no Mac users here. Oh, yeah, hold on.
Okay. Well, I'm one of the Mac users.
Yeah.
I want to say thank you for all the great work. It's been pretty awesome the last year.
Yeah, thanks.
But my major question is, after macOS upgrade, usually it seems to be best to just mute the /nix and rebuild from scratch.
That's
Is there a better way to do this right now, or?
It really depends on. It's hard for us to predict what they're going to do. So the issue is we do have a compatibility shim effectively in the standard env that papers over some of the differences in the impure we have the fundamental impurity, and that thing's changing out from underneath us, and we wrap it in something that makes it look the same each time. And so the short answer is that no, I don't think so. Other than if you keep up to date, we generally try stuff on the betas, and we fixed some stuff in the standard env a couple months before the actual release. We couldn't have predicted the latest screw up, which was Apple breaking the kernel, which is still broken. That's something I haven't mentioned, but yes, don't use Nix on 10.13. But effectively, I don't think there's any better answer there. Well, I mean, you don't have to wipe the entire store, because if you get to new version, as long as Nix itself hasn't broken, then you can always get to a new version and not have to worry about it. But if you use NixEnv a lot, and the NixEnv the installed things might break. So that's the problem.
And also you can brew cask install Nix.
You can. Yes.
Yeah, great talk. Thank you. I was wondering, like, while I agree that the ultimate goal would certainly be to get rid of homebrew and have everyone use Nix, I wonder to what degree can you actually benefit from whatever the homebrew community has to do when they fix stuff? Like, are they in their own dark corner with all the impurity, or is there anything that you can actually benefit from? And what's the story vice versa? Like, can they actually benefit from anything that you have to do to fix stuff?
So I wouldn't say I've benefited too much from homebrew. What I have benefited from is MacBorts, which is another one that I didn't mention. It's a much less flashy package manager and is more traditionally BSD flavored, which has the advantage of having an Apple developer who actively contributes to it, who's also part of the core Apple team. And so he tends to know have useful packages or useful patches for a lot of these packages that have saved us, because anyone building these things open source is going to run into the same issues on macOS, and so we will often steal their patches effectively. Vice versa, the approach they use is just so different. Like it's just so impure. I don't really know how I'd paper over those differences.
Okay, thanks.
All right, last question. No question. All right. Thank you. All right.
Have you looked into making Swift work on NixOS? This really interests me because I come from macOS and have used Swift a lot.
Mm-hmm. I personally haven't looked at Swift on, someone made a Swift derivation, William Kazarin, I think, JB55 made a Nix Swift build. I don't know whether it went anywhere. I haven't actually used Swift myself, so I haven't looked too carefully. But I'd imagine if we can get a good build working, it'll just work on both platforms fairly well. But beyond that, I don't know. Sorry.
All right. Thank you.
Thank you.
Test, test.
Our next speaker is Anton, a fairly new Nix contributor, opened a nice pull request improving the Nix installer, and he is Senior DevOps at Serocal. Thank you.
Good day, everyone. I'm happy to meet you all and be at a conference. Today I'm going to talk about the first experience of a Linux user that tries to use Nix, tries to investigate the technologies and experience installing the package manager inside the Nix. Special thanks especially to Mertens. He made a great in-depth review of my large pull request, and I made a lot of improvements, and he made a lot of suggestions. We collaborated greatly. Also special thanks to Graham. We're planning to work on the installers further. Of course, special thanks to Dolstra, and Pumpkin and other guys. Yeah. I'm going to show the current state that of the installation that user gets from the current official site. Then I'm going to show the modified installation that I made with also with the help of the guys. Strong points of the Nix stack, as everyone know, there are a large number of these strong points, like from the DevOps view. The very important thing is single technology stack, because as a DevOps I need to use Ansible and Chef and Puppet and Docker containers and different technologies. Other than that, and the market is really fragmented. Basically that is why the DevOps specialty exists, because of the challenges of the market and usage of different tools. But the Nix stack of technologies basically does all the most important things, like Nix packages, Nix, NixOS, NixOps, DSNix, and the Hydra, yeah. At the company, we are using this stack in our most important projects, and we are trying to collaborate and contribute, and we develop inside the company the practices, and then we are trying to apply them to the upstream. Yes, also the second strong point is a single central repository. As you all know, in the Nix packages, that consolidates all our efforts on the packages and the structure of the package management. This is really great because not a single, I don't know other examples of such community-driven repository that basically from one point is always the point of reference when you can go, where you know this one repository that you can go and always check how things go together, and and that we all commit to and work in a single repository. Of course, that accelerates our efforts and makes them more easy to process. Yeah, you know the Nix language, and that is really and how it is really powerful, especially for its package-specific language. Yeah, and it is really flexible and have a lot of smart features inside it. Yeah, the other strong point is very strict environment, packaging rules that checks comparing to the other packaging systems. The most of the Linux packaging systems and developer package managers like PIP and other for NPM, they does not check or does the package that installs really uses really have all dependencies declared in the declaration of the package, and most of the Linux distributions also does not. So if you install something like, for example, with apt or Pacman or Fedora, it's forgot, was Yum now. Yeah, they all does not check the completeness of the requirements. So basically, if it happens that most of the developers and most of people have some package already installed, like desktop distribution goes with a lot of packages, and if it happens that some package used from time to time, some binary used by the project you install only from time to time, that can happen that going to be overlooked, and basically there is a very frequent case when maintainer maintains the package. He knows relatively about, he is not the creator of the package, so he does not know all the dependencies. And like in the, for example, in the for the deb packages, yeah, and user works with the deb package, and he finds out that there are some missing dependencies. This word missing dependencies that's why it exists, because the Linux world has this problem of the missing dependencies in the packages, and Nix solves that by applying strict environment rules. You only during the package deployment and compilation, you get access only to the environment that you are provided declaratively. If libraries or binaries was not declaratively declaratively stated, it's not going to compile, it's not going to install, and it's not going to work. This checks the process, and we have much less problems with like missing dependencies then. Yeah, and also atomic rollbacks and so also build reproducibility. Yeah, the more in depth if we're going to say that the Nix saves the state. Nix saves the state of the distribution of the system. Yeah, Nixos. That's why we can have atomical rollbacks, and because of declarative nature, we can achieve reproducibility. Yeah, maybe someone also has some important points to point out here. Like one of great points that I met was the laziness of the language. That's why we can have the single repository, because Nix language is lazy, and it loads only the stuff that it needs inside the very huge single repository. Yeah. Let's consider two user stories. Some regular Linux user, he may be user or for like a couple of years, or like long-term Linux user, decides to look into the Nix technology stack. He heard about it somewhere, or in the second story, when the Linux professional decides to try out Nix, because he also heard about that it solves dependency problems, and it enables rollbacks and save state, and yeah, atomical upgrades. So like Linux professional can be example of such a professional is like enterprise level admins and specialists that deal with really complex setups on the mainframes. They probably they have a lot of dependency problems and version problems on the large setups. So, and those mainframe systems mostly are can be very old for a number of, like more than 5 years old. So Nix solves their problems well. But as more or less experienced users and the professionals, each of them decides to test the Nix ecosystem and try it inside a strict Docker container, because you can play with anything inside a Docker container, then you can, and you don't have side effects on the system. Yeah, basically you have any Linux distribution, you spanning up the container, and you check out the technology, and in any case, even if the user is really stupid, he not going to do any damage to the system. So these stories, like people put a lot of hope in the future in the stack. Like Great Gatsby puts a lot of hope when he looks at the window. Yeah, on the other side. So let's try a live demo of the current experience. Basically, it not only shows the experience inside the Docker, but also experience on the Linux distribution. Because basically, as you know, like there is a lot of differences between the Docker container environment and the hardware level installed distribution. Yeah, I'm going to use the most basic and known to everyone distribution, Ubuntu 16.04. It's a LTS version, and you also can participate with me and go along with me with the process. Yeah. Yeah. Right now we are already inside the Docker container. I have it downloaded. Yeah, probably. Anyway, yeah. You can also download it. The Wi-Fi here. How many people have Docker installed and can try out with me the process? Okay. Okay, yeah. This is really special. Yeah. So let's see that we are in fact inside of the Ubuntu environment. Yeah. As you've seen, system says to us that it is Ubuntu 16.04 LTS. Yeah. So let's move ahead. The Nix installation requires some dependencies. It's also going to be great if we are going to include in installation the explanation of what binaries Nix installation wants before it can work with itself using that binaries. Because falling to the error is not really a great user experience when a user starts installation, and installation falls with an error because it you does not have zip on the system. But when the installation asks to provide the curl and the zip to work, it's other way around. We does not fall with the error. We say to the user what requirements we need to install Nix on the system. Yeah. Then we get in the NixOS, or Nix by itself, download it and run the shell script, the main shell script of the installation. right now we see that Nix tarball is downloading. Yeah, after we downloaded the one-liner was I added the execution permissions. I launched the one-liner. One-liner detects system that I'm using, Linux 64-bit, and downloads the tarball for it. And yeah, we see that tarball was downloaded. It starts the execution process, and the process falls with user is not set error. The thing is about this, by the way, most of the things already solved in my pull request, and also in process happens upstream with solving these issues. This error particularly is really special to the Docker containers, because if we look at the environment, we see there is no user variable here. It's really strange for us at first, because like there cannot be. We have like pass variable, but we have not username variable. What is going on? In fact, this is one of the differences of the containers, because container does not go through the standard boot up process, through the loading of the partition, loading the bootloader, through initialization of the system, and through the login screen. And by the way, the setting of the user variable in the environment happens during the login screen or command login. If we use in the Linux command login, that command executes the so-called login shell. It can be bash or any shell that we want to use for login, and asks us access permission, login and password. And after we log it in, then the user environment variable is set. But because containers not go through the whole boot process, this variable is not set and not present, because login command was not launched. So we need to know that, and we need to be able to work with that, because most of you probably know there is a special Docker container already for the Nix, but for the first, it's not so widely known to the new users. And the second is, what if I want to check out, like I have Ubuntu installation and I want to check out how Nix works on the Ubuntu installation, because like at first I does not know anything about Nix, so I want to have the same environment inside the container to play around. And also the next point why containers, any Docker containers are important, because there are a lot of work happens inside the Docker containers, like the one, as you know, the whole infrastructures and startups. Many startups at the beginning, they does not care about structuring the infrastructure. They basically put everything inside one container, and that container can be several gigabytes in size, and it can have everything inside it, the databases and the web servers and whatever, and the product that they are creating. So if they decide to install Nix there on the already working environment, they're going to go through the same process basically, and they cannot use the special Nix Docker container, because they have already the whole setup inside. inside of the Docker container. We need to export user variable manually, then and launch the installation once more. This is oh, there is no slot. Okay. Okay, so as we've seen, we provided our name and what output installation gives us. It warns us that installation as root is not supported by the script. But if installation says to us that root installation is not supported, why does it continue? It's probably it needs to be an error in this case, but also IMS DevOps does not understand what problems root has on a system that he cannot install or use Nix. Root can become any user and install Nix from any user. So, and what user has more rights on the system than the root? It can be like security concerns. That's when we need to provide the security concerns message to the running under the root, everything. And then installation performs a single user installation of Nix. And then complains that directory does not exist. Please create it by running dir, make a dir with using sudo, basically, the installation, we are root user, but installation asked us to use sudo to access the root permissions, to install into the folder. That's basically because the usage of sudo is hard-coded in the installation. And we already solved that. If sudo is present, if detected user is root, that issue also resolved, basically just by taking the user ID and finding by the user ID the username and providing username in the environment variable if it does not present. So this stage goes well, and then at this stage we check if the root user, it can make this user can make everything he wants on the system. If it is not root user, then we try to find the sudo package, the binary. If the sudo binary is not present, then we are trying to use su. Because sudo is a convenient tool, but it cannot be present on in the all environments at the start. It's present on all desktop environments, but on the strict server environments, sometimes sudo is just if su already inside the coroutils, I think. Why we need to use sudo just for convenience when su makes have all the features that is needed. And by the way, there is also such thing as attack service, as you know, in security. So the less binaries environment has, it's more robust. So if there is already su present, why in the server presence of sudo is debatable. So we see the same output basically to this point where installation says to us that Nix build group is not present in the system, which is understandable because it's a clean system and Nix build group is related to the Nix environment, and it was not created before the installation. If you can look in the Nix container, the same thing happens there before the Nix installation in the Docker container, official Docker container with Nix. There happens the creation of the Nix build group and the creation of the workers for the multi-user installation. But it should be handled really by the installation itself if it is needed. So yeah, and by the way, installation asks us to provide Nix build and workers, while it says at the same time that it's single user installation of Nix. The single user installation of Nix, as you know, does not need Nix build group and by official documentation. If all the builds happen and the work happen under the one single user, we does not need workers to do job in parallel for different users. The workers exist basically to do the job to enable the possibility of parallel builds and work for if different users run processes at the same time. So we need to create the group and workers. And also, I explain all these messages, but new user needs to troubleshoot and find them themselves. He goes to the official documentation and sees that this is the multi-user requirement. And at this point, at last, installation goes well and asks and says that it changed our default shell environment, our default environment, and asks us to use Nix right away to run this line to source the part to the current environment that is running. Basically, one of the next steps we can do is to, if someone installs Nix on the system, probably the person wants to use it. It's logical. That's why we should bootstrap the environment the persistent way with the persistent way, and also with the dynamical way. Because if I'm going to want to use like some shell script or Docker build, I'm going to need to do this action manually to be able to use Nix after this. But we can, by default, make these changes to the current environment, and after Nix installation, we can go right into installing the packages. And by the way, on Linux systems, Nix works in ad hoc mode, so there is no declarative approach there, as I know. So the case of scripting or the Docker build scripting is really probably the most simple and efficient way to make initial installations with Nix on Linux systems. Yeah. So we feel like Gatsby that throws, when we go into all this, we feel like passionate when as Gatsby that throws to his love all the stuff all the emotions he gathered for the years, but after all this, we should to consider what experience the new user gets. Like everything inside works great, but there is a barrier to the Linux world to pass into the Nix. I saw this barrier, and we started to work on it to remove it and make it not just remove the barrier, but to make a really great first impression on the new users. For me, it's the first most important thing. If we create a really smooth installation and person sees that we are user-friendly, and as we've seen, there is work happens it's really great time to do this presentation because the work happens in the Darwin, and the DOSA yesterday showed and presented the new CLI that is more user-friendly and much more user-friendly improvements. So it's going to change really drastically, and the Linux installation goes right with it. Yeah. And also, Fitzgerald says in that book the great quote of him that reserving judgments is a matter of infinite hope. It means that if that only the people that are really passionate and interested to try out Nix pass the barrier, but the people who many people just have a bad first experience and they decide to better to stick with default Linux environment that they are using. Yeah. Now let's dive into the current version that is in the pull request. I especially created the Docker container for it. If you want, you can also try it out. And this also container is great because we can test new installation on it while doing the work in the upstream. As you see around the container, it's a basic disclaimer that inside the container I did with a description of what does container do, and also the description of the workaround about the multi-user environment. As you can see here, to create the group and create Nix workers, because this is not a Nix installation thing, it's a Nix related thing. Basically, Nix expects at this point for this group and these users to exist. The further work is needed to resolve this situation with Linux installation. Maybe we should, I considered at first to do the single user installation and then move to the multi-user. It's like seems like logical evolution. I want to point out that this new version is much like the current version is like 150 lines of code. My version is well documented and well structured, and most cases are solved in it, and it's like close to the 1,000 lines of code, like 800. It's all shell script. It's POSIX. I tried to make it POSIX compliant, so it's not going to work on any Linux distribution, and probably in future also on BSD and also other, like my Windows systems are relatively POSIX compliant, and also so we can collaborate and improve the installation on Windows also by the parts of the POSIX script. Yeah. Yeah, this is old. I'm running now the new installation. As we see, I did, oh, it's green, not really great. I'm going to read aloud. Basically, there are log messages printed out. There are grades of the login messages, as you know. The info messages, more important, are notify messages, notice messages. More important is warning messages. Warning messages mean that if action is not taken, the problem probably can arise. And the error is when the problem arises and it's not solvable. So the solvable problems, like when error happens, it prints out red, warnings are yellow, and the notices that user needs to read and to get the knowledge of what is happening inside the script is green. So yeah, we need to create, as I said, this is workaround. That's why, from my point of view, that's why I'm not included in the current version, because the installation is single user mode, and doing the multi-user mode in the single user mode is not proper way to do the installation. Yeah, we see that installation after this one fix happens fully automatically. Yeah, it informs us that install executed for root. So root mode was the check for root passed. So we just use root rights. We are doing classic Linux package manager mode. I posted it there for users that are not really knowledgeable what is single user mode, what is multi-user mode. If we install from root in a single user mode, this is basically for the user is almost the same experience as using all the package managers. User needs root privileges, and everything happens from the root with the root rights. I make a disclaimer that multi-user mode is possible. Then we see that user environment is not set. Probably we run inside the container. We detect username and report that to user. We report to the user that we find out that Nix directory already exists, and we skip creation of Nix completely directory. And by the way, the directory, as I said, can be created with root rights, using sudo, asking for su, and also the further point going to be done is like if we detect that user has not access to the Nix folder, to the root permissions, we can ask user to provide the path inside home, and we can totally install the store inside the home directory of the user. So user does not require any permissions to use Nix inside the root permissions to use Nix. Yeah. Yeah. And then we report that installation is finished and give them contacts. If something has happened, they can ping on the IRC, in the Twitter, and the other places where GitHub is. So basically, I want to say next is if we look at the Linux world, I gathered the statistic from the DistroWatch. You all know this, but I really crunched the numbers. I summed up the numbers from the first 100 of NICs of the DistroWatch list, and basically NICs OS is half of the percent of the share in the Linux world. So we are really a tight and active community and great community, but we really can benefit from the Linux world, from Linux world embracing the NICs, starting to use NICs, and Linux enthusiasts start to port to the NICs. So that's going to, there is great competition in the Linux world, and there are, as you know, the tools that also compete with the NixOS, Nix tools. But I want to point out that the really important part is canonical Ubuntu creates and puts a lot of effort into the snap packages. They are not pure functionally system, but they solve the case like in some way. And they put a lot of effort. They approach them that from the container approach, and we need to spread. We have like 1 year, 9 months to 1 year to spread the NICs inside the Linux ecosystem, or Snap is going to be like a new Flash, and third-party and proprietary programs going to deploy themselves in the snaps on the old distributions. And Canonical is really happy and puts a lot of effort into the snaps, because they basically tie all users of snaps to using the Ubuntu file system inside all other distributions. Right now, on the last week, there was a possibility to base the snaps on any other distribution, like Ike Doherty and Solus made Steam snap on the Solus, but that's not a really great way, and Ubuntu is going to be probably the most used one. And conclusion, we can have a large business financing and more users if we are going to provide a better, if we are trying to provide a better first user experience, and we probably we're going to have a larger share in the Linux world, and also more financing. Thank you all. If someone has questions.
We're run out of time for the questions. Are you going to be around for the hack days?
Not.
Okay. Yeah. Thank you.